ต่อไปผมขออนุญาตให้อาจารย์นุเผ่าพูดเรื่องอินซานะครับอันนี้ก็เป็นลูกศิษย์ของอาจารย์แอนดี้นะตอนนี้อยู่ที่รีดก็เป็นสำหรับทีมอินซาก็เป็นทีมงานที่เข้มแข็งอันหนึ่งนะของเรานะครับผมครับเชิญครับอาจารย์
ครับสวัสดีครับก็ภาษาอังกฤษนิดนึงนะ Okay. Hi everyone. So today I really glad to have opportunity to come back here again to give a talk about the beyond land subsidence InSAR for comprehensive deformation monitoring. So today I will give you a really up-to-date land subsidence in Bangkok and vicinity area. So back to more than 10 years, we have such a difficult time, because when we are trying to use the data from INSAR satellite, is like the cost of the data very high. So to start studying the InSAR is pretty difficult. But luckily at the time, I still work at GSTAR, Geoinformatics and Space Technology Development Agency. So I can get the data from my organization. But nowadays we are lucky that we have the data from Sentinel 1, 2, 3, 4, 5, 6 from ESA, European Space Agency, which is really important and make the remote sensing market like increase, and we have no problem with the data anymore. So using the data from satellite is very important because compared to, I come from the survey engineering field, right? So mostly we do something, measure something on the ground. But the problem is that when you are trying to measure things on the ground, so something that you can do, you can measure just point by point, right? And then when you use the satellite, you can see the whole area, which is very important, and you can get the idea about the movement of the Earth. And this is the legend, this one, Geodetic 2 project, which is the collaboration project between Thailand and EC, European collaboration. So this is very important that I have the opportunity to start working on that project. We studied the sea level rise from multi-satellite altimetry, like from 1993 to 2009. And then we also study the coastal erosion and see the coastline, the shoreline. And then we also, try to understand the hydrogeological setting in Thailand for the central floodplain. And we understand, the difference in soil layer, which is really important, and is it the base of our research nowadays. And it is also my work, like we see the different subsiding, around Bangkok and its vicinity area, and you can see this is the subsiding in different level. And this is a really first InSAR results published at the International Journal of Remote Sensing. And I used the data from RadarSat 1, data from Canadian Space Agency, which is, at the time, if you think about the cost of the data is around, almost 100,000 baht per scene, very expensive. At the time, if you want to set up the project about using the data from SAR satellite, I think more than 50% will be the data cost, compared to nowadays. And on that project, we studied the sea level rise, we studied the land subsidence, and then we also studied the plate tectonic drawdown and then combine together, and then we can simulate the sea floods of coast of Greater Bangkok with my Professor Iti Sri Satyawong and Dr. Pani. They simulate the flood map of 2060. And I think this is the dike. Yeah. Not just in that area. And for the current work, I'm trying to, more than 10 years, keep studying on using the SAR interferometry to measure the subsidence in Bangkok and keep study. And the problem is that now we don't have any other data from any other measurement, especially leveling data from Royal Thai Survey Department. We only have the data from GNSS, but it's okay. But it's point by point, But leveling that we Royal Thai Survey Department used to measure at the time, I think more than 20 years. And then they just stopped working on that because they said that's not their responsibility. Yeah, that's why. So it means that in Bangkok we have no subsidence data more than, I think, 6 to 7 years. Only InSAR data available up to now. So keep in mind that. So the issue and challenges of my study is that the monitoring and data collection, the high cost of traditional measurement, which is, if you try to do the leveling measurement again, it's going to take around 6 to 7 million baht per year. And then that's a lot. And it's time consuming process. And also, inability to cover all structure because it's just point by point. As I already mentioned, it's around maybe with the leveling, with the whole leveling, if I remember, if the benchmark still exists, it's going to be around, I think, 1,000 or 2,000 points. Compared to InSAR, that's a lot. Yeah. And then we need for long-term data management, and then the potentials of InSAR come to, I would say that, bridge the gap of the measuring the data in the area. And then what I tried to do, the last one, the proposal for a center of excellence, because actually back to more than 7 years, I worked at Asst, and I realized that I should do something. I should extend my knowledge. I have to do something to give my experience and anything about InSAR to the student. That's why I decided to become the lecturer in the university. And then the objective of the project is to develop an efficient operation method to reduce the time, manpower, and cost associated with the traditional land subsidence, and then to enhance the frequencies and the accuracy of land subsidence monitoring in Bangkok. And then to integrate all of them, satellite radar data with the other surveying technique all together. And then this is the whole project from FEMCE. And then this is my extensions of this project, and try to use the data from the satellite. It's very big data, It takes a lot of time to do the process. We, try to do many things, like develop the hardware and software and all those things. And then let's take a look at the satellite available. For now, we have only Sentinel-1, 1A. We have lost Sentinel-1B. Yeah, it's about a technical problem or something. But I think InSAR have the plan for Sentinel-1C.
Yeah, it's going to be launched at the end of the month.
Yeah. So it's guaranteed that we still have data ongoing. So I have 12 years before retiring, so enough time for me. Yeah, to play, to still keep playing with InSAR. Yeah. And then the concept of radar is pretty easy. It's like you transmit the signal, and it's reflect something like on the earth, feature on the earth, and then receive the signal back. And then when the signal, reflect the feature on the earth, it come back with different what we call the strong signal. And then when the satellite come and repeat again and again, the recurrent period, repeat period is around 12 days with Sentinel-1 data. So it means that every 12 days, the satellite come and capture the image in the same area again and again. We call this is the time series data. And we use the long-term data and to process something that moves very slow. Not the earthquake. Because the earthquake, we only need the, two data, before and after. Because the strong signal of deformation, will represent on the radar signal. But for the long-term movement, like 1 millimeter per year and no more than many centimeters per year, is have to use the time series data, keep working. And we kind of lucky that we have very crazy people here. Keep doing things, for a long time, more than 10 years, and still, keep working on that. Like Wim, and then Femke come, and then keep working on that. I'm really happy with that. And then also the people here, Dr. Andy, from Leeds University. I knew him for a long time since the geodetic, and he gave me a lot of knowledge, like doing the knowledge transfer, give the suggestion and anything to make InSAR happen in Thailand. And the result from UK team will be available after my presentation. And this is the most up-to-date Land Subsidence date. So this is what I said to you that I'm trying to do, the National InSAR Center of Excellence at Kasetsart University. We call in short, nice. Yeah. I want to do this because I don't want to lose my knowledge and experience about this. I have to think about, before getting retired, to give it to my student. Yeah. And we kind of have the facility. We have the office now. And then I try to get the funding from many sources, and then try to build up my office, and then also the facility, the hardware, the software, which is very important for InSAR. This is my team. They are young. They are bachelor student, master student, and PhD student. So they have the presentation. They can do InSAR processing for now. So Thailand not lost the knowledge about InSAR, I think. And not just only in Bangkok. We used to have another project to study dike monitoring in Nakhon Sawan. We also have the other project with electric authority, generation authority Thailand, at the we call the Lamtakong Cholapa Watana at the Nakhon Ratchasima province. Yeah. And this is the most up-to-date InSAR in this area, Bangkok and its vicinity. So we run the process the Sentinel-1 data from 2018 until 2000 until now, actually. So the last image maybe on September. So we found that the subsidence rate is still okay, I think, from 13 and 20 millimeter per year. So it's around, the magnitude around 3 centimeter per year. So compared to the result from previous work, it's still okay. Yeah. The maximum rate will be around this area. And in this area, I think Kun Anirudh from Department of Groundwater Resources will give you in-depth on this area, what's happened. And this is the result that show the Department of Groundwater Resources that which area should be pay more attention on. You cannot, find any other data the same as InSAR because it gives the idea of the whole area. Yes, and then also Suvarnabhumi Airport. I really surprised that on the runway. Yeah, it's a runway. It's kind of compared to other part, is like subsiding more than the other place in that area. And then I'm trying to, ask my student, to pick up the area, not actually a significant subsidence rate, but just pick up some area to show you some sense about the subsiding. And this area is the Nakhon Pathom province. So, yeah. And here is Ban Phao, Samut Sakhon. It's about 20.51 millimeter per year. And here in this area, Puttamonthon is not very strong subsiding. Here is Samut Sakhon and Nonthaburi, Phra Khanong, Bangkok. And Teparak. Teparak is okay now because the last time that we have the result, we found that at the Teparak, we have a very strong subsiding around 3 centimeter. And here's Bangpo Industrial Estate. Because I try to pick up some industrial estate because in the areas they use the groundwater pumping. They still, even we have the regulation to control the groundwater pumping, but it's okay for Bangpo. And here is Bang Chan Industrial Estate. That's still okay as well. But Suvarnabhumi Airport, they have to pay more attention on that. But actually, I gave the result to the AOT about the more subsiding on this runway. Yeah. We found it many times that we process the InSAR, but it's still. And here is the Lat Krabang Industrial Estate. And surprisingly, because here is my village. I didn't ask my student, to capture my village. They didn't know. And when they sent me the presentation, and this is my house.
I think you showered too much.
Yeah. Yeah, and you know, I thought about at a time, like, should I show this picture? It's gonna make like my house pricing's going down or not. But yeah, but it's okay, but because it's real, you know. Well, and here is the Thanyaburi, Pathum Thani province. And then, as I already mentioned in my topic, is that beyond the land subsidence. So I mentioned to you that what I have to do more and what I have to do after this, not just only, you know, trying to measure the subsidence in Bangkok and any other area, but what I have to do is that I have to like build something, creating something, you know, to make the challenge in the field. So I try to make what we call the satellite survey unit for calibration and validation. So this size will be not just only, you know, for people in Thailand, but actually if the owner of, the other space agency around the world, if they have the SAR satellite, they can use this at the calibration site as well. Sorry. So the importance of corner reflector, you know, for InSAR is to enhance the signal strength and the target specific observation point, the stabilized radar signal in complex area, serve as calibration and control point, and it's going to provide consistent scatter in scarce area. So it's going to be, you know, answer the questions about the accuracies of InSAR. You know, many years, people always ask me about the accuracy of InSAR. What about the accuracy of InSAR? I told them that now only remote sensing data available. Even we have the GNSS, but GNSS still have like not too many points to compare with InSAR. And we have no data from leveling survey. So the corner reflector will be the answer. This is the master plan. We collaborate with Electric Generations Authority Thailand. And then this site will be located on top of the mountain at Nakhon Ratchasima province, as I already mentioned. And the site, at the beginning, I designed for 3 meter, very, very huge. But it's about the budget, so yeah, think in my imagination, you know, but we reduce the size of my dream, you know, from 3 meter. So right now, come back to the real world, just 2.4 meter. Yeah, it is enough. Enough because of my budget, not because of, you know, in terms of the technical. Yeah, here is the location, and we just constructing. Well, it's gonna be finished around the end of this month, hopefully. Yeah, this is the foundation, and here, yeah. As Wim already mentioned, I'll try to be I'll try to be like Super Joe, yeah, like Wim, right? Everyone call him Super Wim, right? I'll try to be, yeah, because I work in this field more than 10 years. So this is the design of corner reflector. Finally, like 2.4 meter. Well, but it's still big, too big. Here. Very big. And another, you know, the more difficult is that no one have the experience doing something like this. So it's very difficult to find the contractor. Very difficult. I spent like more than 3 months. You know, the first one come, and then No, 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 no. And the second one, no, 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 no. Yeah, many contractor, and finally we got it. And then we already calculate and adjusting the corner reflector position, because when satellite come, we have to make the positions of corner reflector to reflect the signal from satellite. So this is in the ascending orbit, we already calculate the azimuth angle and then the zenith angle. This is for descending orbit. And then the top 5 challenges in monitoring with InSAR. I think the high cost of the data will be okay for now. So because we have the data available for free, right? And then the lack of InSAR expertise, okay, I'm working on that. And hopefully in the future, we gonna close this gap. And for the other thing, we can solve with the technical term. And then that's why I already, many times I like to mention about because I work at the Faculty of Engineering. In my faculty, and especially Department of Civil Engineering, like many people, they are civil engineer, they are geotech engineer. But what I'm working on the remote sensing. So they always have questions, always curious about how you can measure things on the Earth using the satellites. They don't believe much. So that's why I have to show them, I have to educate them about we can work together using the InSAR, using the geotechnical instrument, working together, not just only study the land subsidence, right, in the area, but with this technique, we can use for, doing the other application like infrastructure monitoring, like dam, dike, road, bridge, anything. But I have to make them believe first. But luckily, we have the ISO TC 182/WG2. They focus on standardizing geotechnical monitoring and began in collaborate InSAR as a valuable technique in its guideline. So it's good start. So, and I try to make it InSAR and geotech go together, making like engineering and scientific come to work together. And then that's all my presentation today. Yeah. Thank you. So,
I have a question.
no, you cannot have question. Okay.
So you showed your latest results for the Bangkok areas. As you said, it runs from -20 to plus something.
Yep.
This was my question.
What
Yep.
does this
This is relevant.
Okay. I think Kun Anirudh from Department of Groundwater Resources can answer this question. Like sometimes, when the groundwater have more water, and some area will go upflip a little bit, and some area going down. And it's not all area going down.
Are you sure? Because InSAR is relative. You're not measuring the absolute.
Oh yes, sure.
So actually you should calibrate the scale.
Sure, I have to calibrate, but
So it's a
the upflip and subsiding is not. It can happen in Bangkok. Yeah, confirm with the groundwater resources department. Yeah, but surely last time when I have done my previous work, I set up some strongest points, and then on that point we assume there's no movement. Yeah, and make it like the reference point. So that's why I said to you that beyond the land subsiding, so we have to have the reference point. So that's why I trying to make the corner reflector. Yeah.
Do you put, well, you don't put GNSS on the corner effect?
I will.
Oh,
I will.
then you can calibrate exactly.
Yeah, sure.
And I'm sure the scale will change. I think you will see little uplift because.
Here. The GNS will be here. Yeah.
Because most things go down. There's not only things can go up,
Yeah.
temporary with ground level, but not over a couple of years, unless you have tectonics. And there's no
Okay.
active tectonics in Bangkok.
Okay.
So I think the scale might shift a little bit, you know. So you
Maybe. Yeah.
feel a
Maybe.
millimeter but it's the relative. It's
Yeah.
most important.
Yeah. So that's why I didn't talk much about the rate. So I'll talk much about the spatial accuracy and spatial distributions of the data, which is very important that we can get the sense of the area where is the place that we have to pay more attention on. Like, sorry. Yep.
Can I
Yep.
ask you to change talks now and have questions later because I'm communicating with people online.
Okay. Sure.
And, I'm sorry about this.
Oh, that's okay. Yeah. Thank you.